Now we are going to see geometric progression, that is GP. GP, sometimes it is called exponential arithmetic, exponential progression or exponential sequence. Exponential sequence. And a geometric progression is just a sequence that have a common ratio. A sequence with a common ratio. That is a term, and the next term is found by either multiplying or dividing by the common ratio. For instance, I may be given some terms like 2, 4, 8. And I can say that these terms are geometric progression. Why? Because it has a common ratio. What's the common ratio here? The common ratio is 2. Meaning, if I take 2 and multiply by the first term, which is 2 here, I am going to get the next term, which is 4. And if I take the same 2, multiply by 4, I will get the next term, which is 8. If I want to get another term, I will multiply the next term, which is 8 by 2, having 16. So any term that have a common ratio, it's called as geometric progression. And also in geometric progression, we have terms, the terms formula, the sum formula, the geometric mean, and the sum to infinity. Now let's see the term, nth term of GP. The nth term of GP has a formula which says Tn is equals to ARn minus 1. This is the formula for nth term, where this Tn is what we call the last term. A here, as usual, is the first term, while n is number of terms, and the last one, which is r, it's called the common ratio. And to get this r, for instance, if I said I am having some GP terms A1, A2, A3, and the rest. So to get r, you divide the next term by the previous term. That is this one divided by this one. Or if you like, you may divide this one by the previous one. That is how to get r, or common ratio of geometric progression. For instance, if I said there I am given some terms 1, 3, 9, 27, these terms are GP because they have a common ratio. So if I am to find r, which is the common ratio, I will just say my r is equal to 3 divided by 1. That is this term divided by this one. 3 divided by 1, you are going to have 3. If you like, you might say 9 divided by 3, which is the same thing as 3. If you take a look, you will see that if you either divide this one by this or this one by this, you are going to have the same common ratio. So this is it. Now let's take a look at example to see how we are going to find a term in a geometric progression. Find the 6th term of the GP. Let's say this is the GP. Let's say 2, 4, and 8. Solution. Assuming we are given this GP, we are having only 3 terms, but we are asked to find the 6th term. So for we to find the 6th term of the GP, we use our nth term formula, which says Tn is equal to ARn minus 1. Our n, the 6th term we are asked to find is our n. That is, our n is equal to 6. The first term is the first term that comes on the GP, which is 2, while the common ratio, which is r, is equal to next term divided by the previous term, that's 4 divided by 2, and this is equal to 2. So having all this, we just input in our formula. Tn, that is T6, the sixth term, is equal to A, which is 2, multiplied by R, R is 2, N is 6 minus 1. And this is the same thing as 2 into 2, this and this is 5. Then the next thing is, please let's take a note of this. I cannot say 2 times 2 to get 4 for 5. This is totally wrong. For we to simplify this, we have to take away the power first. Then the result we have will multiply by this 2. Like this. We are going to have 2 into, that is 2 power 5 is 32. Then at last, you multiply 2 by 32 to get 64. So the sixth term of this GP is 64. Let's see another example. After this one, if the second and let's say and fifth term of GP are 3 and 81 respectively. Let's find common ratio, or common ratio first term, or let's find its seventh term. For instance, if we give an example like this, if the second and fifth term of GP are 3 and 81 respectively, we are asked to find its seventh term. How? In this case, the series or the sequences of terms are not given, but we are given some information. That is the second term, which is given as 3, the fifth term, which is given as 81, to find it. So we are going to make use of this. That is the second term, which is second term, they said it is what? 3. And the fifth term, that is T of 5, is equal to 81. So having known that the second term and fifth term are given, then you just recall the formula which says Tn is equal to A R n minus 1. From here, if I take this second term, I know that my n here is what? Is 2. So just replace my n by 2. Having T of 2 is now equal to AR. This is what? N, but 2. 2 minus 1. That is 2 minus 1. So, but the second term is given as 3. So I will replace this one by 3 now. I'm going to have 3 is equal to AR. 2 minus 1 is 1. I cannot put it, the same thing. It's not allowed to put 1. Just leave it as R. So I might call this equation 1. So now let's go to the fifth term here. The same thing, I'll just come to my formula, replace n by 5. So I'm going to have T of 5 is now equal to AR 5 minus 1. But T of 5 is given as 81. So I'm going to have 81 is now equal to AR 4. I call this equation 2. So having our equation 1 and 2, let me manage this place. We solve for R and A in 2 and 1. Our equation 2 says 81 is equal to AR4. Our equation this says 3 is equal to AR. So in case here you are going to divide, but if you recall, in case of arithmetic progression, what we normally do here is subtract. We subtract. But in case of this one, we are going to divide. So now 81 divided by 3. We are going to have 27. which is equal to A divided by A is 1. It will go. Then R4 divided by R, that is R1. We can take it like this. R4 divided by R1. According to law of indices, you take one R, you subtract the powers. So we're going to have R3. So therefore we have only R3 here. So now we are looking for R, and we just take the cube root of this 27 to get our R. So this implies R is now equal to cube root of 27. And cube root of 27 is just 3. That is a number power 3. That is 3 power 3 will have 27. So now, having our R as 3, just put R is equal to 3 in either equation 1 or equation 2. A, R, and our R is 3. Just divide through by 3 to get your A. 3, 3. Therefore, A is equal to 3 over 3. That is 3 over 3 here. So it's equal to 1. So now we have our A, which is first term, as 1, and our R, which is common ratio, as 3. The next thing is just to find the seventh term, like this, by the use of the formula also. Now the seventh term. Now the seventh term. That is T of 7. Applying our formula A, R, N, and our N is 7 minus 1. Which is equal to A. We found A to be 1. 1 multiplied by R, found R to be 3. Just put it. Then this and this is 6. So the next thing is 1 multiplied by 3 power 6. What is 3 power 6? 3 power 6 is this 27 whatever, let me check. Three power sorry, it's 243. So now 1 multiplied by 243, we are going to have 243. So this 243 is the seventh term. Okay, now after these two examples, let's